he's going to make this function, it's differentiable on ik, and he's going to bound it by this derivative here, and he says it's plus or minus 1. So he's doing a more general form, I think, in the book, where I think the teacher in the computer was doing was trying to use the numbers and was doing separate functions for each one, and this is more of a broader approach, a little cleaner, I guess, since you can't catch everything at once.
I'm always curious, there's a subscript k, but it doesn't seem to be operative there in that line. F prime.
I was wondering that too, because he doesn't really use the k at all, except for to put it there. I would almost wonder why he put it there.
Yeah.
Unless he's trying to say it's that interval, within the interval AB, saying that it's between some interval n to k, but he never uses k. So page 70. Which, what are you looking at? The function there just kind of makes the funny picture.
I did not understand why he really didn't use k. He introduced it as a subscript.
And he never used it.
Oh, okay. I in k is one of the open intervals removed in the construction process for the SVC system. So apparently the k refers to, see, if he would have been kind enough to give us that construction where he used the k, we'd see it. So it's kind of hidden here. It's part of the SVC set construction. And then he never mentions it again. He just carries it as a subscript. Can we figure out, did he actually draw the first few approximating sets to this set we're talking about here, SVC set as measure 1/2? Apparently what we got to do is take away, I want some of it. It has to be, what geometric series is going to have someone have?
So I think we're taking away 8 of 8 that way and 8 down.
That's the quarter die. If I take away a quarter and a constant ratio is 1/2, I start with a quarter with the first term over 1 minus 1/2. That's a whole. So she's right there. If you can manage to take, if you start with taking away a quarter and take away a half subsequent figures, the total takeaway is 1/2. So you're left with 1/2. Right? Positive measure 1/2, which is what this set really is. So maybe that's an I and k, but where's the k? What's evidence k?
So suppose I and k equals the open set AB. So I think it's just any open set that's being taken away during the construction process.
You know what I bet it is? It's the k set that's taken away at the end level. So I11 would be that 1/4 that you took out of the middle, because there's only one of those. It's the first level, but then the next part of the construction is to go, what's the center point of the remaining thing? It's 1/3, 3/16. Yeah. 3/16 and 13/16, and take away a centered 1/8, which would be a 16th for either side, right? Yeah. It's funny. Now, I would say that first interval on the left is I 2, 1, and the one on the right is I 2, 2. So F11, F21 and F2. Yeah, I don't know whether it's one way or the other. Yeah, that's what I'm trying to relate it to. That's what he's calling it. He seems to do this. Yeah, on Article 310. But he does it with generality, and then he comes back and tells you it's 1/2. Right? Look how he starts this on 310. A1 is positive unless the over A1 to 1 minus. And then he allows A1 to be anything later. And in our case, A1 is 3/8. I think so. The construction on page 67, let A1 be positive and less than 1/2. Fine, I'll let it be 3/8. Remove the open interval, 3/8, to 1 minus 3/8, that's 5/8. So that's exactly what we did. Okay. Yeah. Okay. And we're left with close, that's blah, blah, blah. Yeah, sure. A2 is positive and less than 1/2 A1. Now, he's letting A2 be arbitrary. It's not a constant ratio. That's what's killing me. Yeah, that is what he did. Yeah. All right. So this is much clearer now that we're doing questions. So we start out taking away a quarter, and we take away.
There's the Cantor set.
Yeah.
So that's a 1.
Yeah. Well, we're getting a set of positive measure 1/2, and that's what the idea is. At the end level of the construction is H1. So. The first level you have 1. N minus 1. A goes from 1 to N, 1 to 2 to N minus 1. At the second level, you've got 2 to the 1 intervals taken out. All right, so that establishes that. All right. I like your PowerPoint. That's making more sense to me.
So we have the sign and we flipped it to the other side.
So we just make a lot of smaller and smaller copies of that thing. And flip it. And then just kind of put all of them on top. If it survives. So
it's really the endpoints that, like you said, the endpoints that make a huge difference in this.
it's all the else, but yeah.
So that's where you start stacking out.
So we're looking at sort of between 0 and 1/2 there, and it's symmetric about 1/2. And then that other little one is part of the next n equals 2. And then there should be one out there about 13/16 or wherever we said that looks like that. And then we're going to do this again midpoints of what's remaining. And we keep going. And we get 2 ringer points at the end of each one of these, right?
And then we're going to kind of say, like, well, this is where I felt the book actually did a better job of explaining the endpoints. He's going to say, okay, well, if our x is, let's see,